Hello everyone. Today's topic is classification of microprocessors. Microprocessors can be classified based on their specifications, applications, and architecture. Based on the size of the data that the microprocessor can handle, they are classified as 4-bit, 8-bit, 16-bit, 32-bit, and 64-bit microprocessors. Based on the application of the processors, they are classified as general purpose processors, microcontrollers, special purpose processors. So here general purpose processors are those that are used in general computer system integration and can be used by the programmer for any application. Common microprocessors from Intel 8085 to Intel Pentium are examples of general purpose processors. Microcontrollers are microprocessor chips with built-in hardware for the memory and ports, as I have discussed earlier also. These chips can be programmed by the user for any generic control application. Special purpose processors are designed specifically to handle special functions required for an application. Example, digital signal processors are special purpose processors. These have special instructions to handle signal processing. Application specific integrated circuit, that is ASIC chips, are also examples of this category of microprocessors. Based on the architecture and hardware of the processors, they are classified as follows: RISC processors, CISC processors, VLIW processors, superscalar processors. So here RISC stands for Reduced Instruction Set Computer and CISC stands for Complex Instruction Set Computer. Basically, there are two approaches of the design of the control unit of a microprocessor: hardware approach and software approach. To execute an instruction, a number of steps are required. For each step, a number of control signals are generated by the control unit of the processor. To execute each instruction, if there is a separate electronic circuitry in the control unit which produces all the necessary signals, this approach of the design of the control section of the processor is called RISC design. It is hardware approach. It is also called hardwired approach. Now, if the control unit contains a number of microelectronic circuitry to generate a set of control signals, and each microcircuitry is activated by a microcode, this design approach is called CISC design. To execute an instruction, a number of micro operations are performed. To perform each micro operation, a micro instruction is executed. For each micro instruction, there is a microcode. When a micro instruction is executed, a set of signals are produced to perform a micro operation. Microcodes are stored in a ROM. This is software approach of designing a control unit of the processor. To execute an instruction, a microprogram is executed. A microprogram is written using micro instructions. This is called microprogramming. So, again, RISC processor, as I've already told you, RISC stands for Reduced Instruction Set Computer, and it uses the hardware approach of the control unit. The other features are it is designed to reduce the execution time by simplifying the instruction set of the computer. Using RISC processors, each instruction requires only one clock cycle to execute results in uniform execution time. This reduces the efficiency as there are more lines of code, hence more RAM is needed to store the instructions. The compiler also has to work more to convert high-level language instructions into machine code. Some of the RISC processors are PowerPC 601, 604, 615, 620, etc. The major characteristics of a RISC processor are it consists of simple instructions, it supports various data type formats, it utilizes simple addressing modes and fixed length instructions for pipelining. It supports register to use in any context. One cycle execution time. It load and store instructions are used to access the memory location. It consists of a large number of registers and it consists of less number of transistors. So the next processor, CISC processor, as I've already told you, its control unit use the software approach, that is the microprogramming. The other features of CISC, that means complex instruction set computer, are it is designed to minimize the number of instructions per program, ignoring the number of cycles per instruction. The emphasis is on building complex instructions directly into the hardware. The compiler has to do very little work to translate a high-level language into assembly level language or machine code because the length of the code is relatively short, so very little RAM is required to store the instructions. Some of the CISC processors are IBM 370, etc. Its architecture is designed to decrease the memory cost because more storage is needed in larger programs, resulting in higher memory cost. To resolve this, the number of instructions per program can be reduced by embedding the number of operations in a single instruction. Characteristics of CISC processor. First is variety of addressing modes are there. Second, large number of instructions are there. Third is variable length of instruction formats are there. Fourth is several cycles may be required to execute one instruction. The next point is instruction decoding logic is complex. And the last point is one instruction is required to support multiple addressing modes. So based on the architecture, I have discussed two processors, RISC processor and CISC processors. The next processor I will be discussing is very long instruction word processor. So very long instruction word or VLIW refers to a processor architecture designed to take advantage of instruction level parallelism. It is less complex approach to allow higher performance, that is multiple operations performed simultaneously or level of parallelism increases. In VLIW processor, instruction consists of multiple independent operations grouped together. There are multiple independent functional units. Each operation in the instruction is assigned to different functional unit. All functional units share the use of a common large register file. In VLIW processor, compiler is responsible for static scheduling of instructions, that is, the compiler finds out which operations can be executed in parallel in the program. Compiler groups together these operations in single instruction, which is very large instruction word. The instructions within a VLIW instruction are issued and executed in parallel. Since in VLIW processor, one VLIW instruction word encodes multiple operations which allows them to be initiated in a single clock cycle. VLIW instruction contains operands and operation to be performed by the various functional units. One VLIW instruction encodes at least one operation for each execution unit of the device. So length of the instruction increases with the number of execution units. VLIW instructions are usually at least 64 bits wide and 1024 bits wide to some architecture. The next processor is superscalar processor. Superscalar refers to a machine that is designed to improve the performance of the execution of scalar instructions. Superscalar is in contrast to the intent of vector processors because in most applications the bulk of the operations are on scalar quantities. In superscalar processor, instructions execute independently in different pipelines. A superscalar processor is a CPU that implements a form of parallelism called instruction level parallelism within a single processor. Superscalar processor executes multiple independent instructions in parallel. Common instructions like arithmetic, load or store, etc. can be initiated simultaneously and executed independently. This is more commonly used in RISC. The main principle of superscalar approach is that it executes instructions independently in different instruction pipelining, which leads to parallel processing, thereby speeding up the processing of instructions. In superscalar processor, there are multiple functional units, each of which is implemented as a pipeline. Each pipeline consists of multiple stages to handle multiple instructions at a time, which support parallel execution of instructions. Superscalar processors are much faster than scalar processors because it increases throughput as the CPU can execute multiple instructions per clock cycle. Again, I am repeating, these type of processors are much faster than scalar processors because it increases the result or throughput as the CPU can execute multiple instructions per clock cycle. A scalar processor works on one or two data items, while in superscalar processor each instruction processes one data item, but as there are multiple execution units within each CPU, thus multiple instructions can be processed separately, can be processing separate data items concurrently. A superscalar processor typically fetches multiple instructions at a time and then attempts to find nearby instructions that are independent of one another and can therefore be executed in parallel. If there is any dependency between input and output of instructions, then that instruction cannot be executed parallelly. So up to this much only, I'll be ending the class now. In the next class, we will discuss about memory. Thank you.